Hey everyone, I just want to do number 71 on page 309. This is for section 4.3. And here we go. So we have this guy wire running from the ground to a cell tower. The wire is attached and it's got the picture labeled here on the right, 150 feet tall is where the wire is attached, and the angle is 43 degrees. So they want to know how long is the guy wire, which is something you might need to know in engineering if you're constructing this tower. So that guy wire is that side right there, which we know is the hypotenuse, because that's the longest side of a right triangle, opposite or across from the right angle. So I'm going to redraw this up here, and if I want to find that, I'll just call it C, because you know from the Pythagorean theorem, we often call the hypotenuse C. And so I'm looking for, I have an angle, and I know the opposite, and I'm looking for the hypotenuse, so I want the trig function that connects the opposite and the hypotenuse. So let me write SOHCAHTOA, and I can look at this and go, oh, opposite and hypotenuse, that's sine that I want to use, SOH, opposite and hypotenuse. So I'm going to write this down, sine of theta equals opposite over hypotenuse, that's the formula I'm going to use. So sine of 43 degrees is 150 over C. Now the tricky part about this problem is that we have C in the denominator. We can't just multiply by 150, we have to get the C out of the denominator. So we're actually going to multiply by C on both sides as the first step. This is the trickiest of all of these. Then once you multiply by C, now we can get rid of, or get C all by itself by dividing both sides by sine of 43 degrees. And when you do that, it's just a matter of punching into the calculator, make sure you're in degree mode, and you get 219. Now, let's pause real quick, make sure it's 219.94, whoops, not degrees, that's measured in feet there. Does that seem reasonable? And the answer is yes, because it's got to be longer than 150, but it's not going to be more than twice as long as 150. It's going to be a little bit more than 150, so that seems reasonable. So that's the answer to part A. To get part B, you could set up another trig where you have adjacent to the angle, so you could use cosine or tangent because you know the other two sides. But when you have two sides of a right triangle, the easiest thing to do then is, and we're looking for that bottom A there, is to use the Pythagorean theorem, in my opinion. So I'll set it up for you here unless you finish it on your own. A squared plus B squared equals C squared. First, I would square 150, and then I would subtract that number from both sides. That way you get A squared by itself, and then take the square root of both sides, and you have A all by itself. Thanks for watching.